Today's topic is Python, right, as a programming language. And before we get into the programming itself, let me give you a little bit of introduction about this programming language, as well as a little bit of introduction about me as well. So to begin with, my name is Talat Fakhri, T-A-L-A-T-F-A-K-H-R-I. You can find me on LinkedIn if you want. And I've been a programmer since I was 10 years old. And the areas I have made projects is in web development, machine learning or AI, blockchain development, big data, as well as computer security. And today we will be dealing with a special language called Python. So with that out of the way, let's get going. Python is first of all, a general purpose. Unlike programming languages, which are not general purpose. For example, SQL is not general purpose. Right? So SQL language is only meant for relational database management system. So this is not general purpose. Yeah, but Python is a general purpose, extended high level language. Okay, and then another word is high level language. So what is the meaning of high level language? The meaning of high level language means that usually in a computer system, right? And you know that computer only deals with zeros and ones, right? That's all it can do. So this is the machine code, right? And on top of machine code, there are some languages that interact with this machine code, like assembly language, right? And then there are some languages like C, they interact with, these kind of languages. And then there are languages like Python. So Python has a very indirect link with the machine code, right? So as you go higher and higher, you get into higher level languages. So Python is a high level language. Another good feature of Python is that it can be extended. So it is extensible. So Python comes with its own features, but you can actually extend Python to include more new kind of feature which are suitable for you, right? Okay, now what are some of the good uses of Python? Some of the good uses of Python, it could be because you are able to get results from Python very quickly, right? So it is an interpretive language. It uses an interpreter. Interpretive language. Interpretive. So what does it mean? It means that in order to run the program, it doesn't have to first compile into machine language. It can just run without compilation. So the turnaround time is very low. So you write some code, immediately you can see the result. So anything which requires quick development, Python is very good for it. And it also supports many programming language philosophies. What is a philosophy? First of all, a philosophy is something, a way of living or a way of doing things. It's called a philosophy. So, so in programming languages also, there are many paradigms of philosophy, a way of programming. Okay? And Python supports all those ways. So if you are, if you are a functional programmer, you can use Python. If you are an object-oriented programmer, you can use Python. You're a procedural programmer, you can use Python. So all these are like different ways of programming, and in Python you can program all these styles. That's why it's a very flexible language. Yeah. Okay. So I was saying that Python is a very flexible language. Also, just so you should know that the inventor of Python is Burger Van. So he used to work in Google, but now he is working in Microsoft, right? So you can see that the influence of Python is spreading among all companies. So that's why Microsoft is also becoming very Python friendly. Many of its applications have Python support. So, and Python is basically an it is scripting language. I mean, it started off as scripting language. Okay? What is a script? A script is a program that controls other programs. Okay? So scripting languages are good for quick development and prototyping because they're good at passing messages from one component to another and at handling uh, stuff like memory management, which C programmers have to and C++ programmers have to deal with. In scripting language, you don't have to do memory management on your own. The programming language does all those things in the background. But of course, Python has grown far beyond being a scripting language. And now it is called dynamic programming. Instead of being called scripting language, it's called dynamic programming. Why it is called dynamic? Because the moment you do a change, you can immediately see the result of the change. You don't have to go through the long process of compiling and rerunning. You don't have to do all these kind of things. Okay. One guiding principle of Python has always been clean code. When you're writing code, but you write code in a very messy manner so that other programmers are not able to read your code properly or understand your code, then it means that you're not a very good programmer. But Python enforces clean code. Also, another thing about Python is that, as you know, like computers store everything in ones and zeros, right? But humans need to work with data in more complex form, like text, right? A language that supports complex data is said to have high-level data types. So under the hood, text or integer or a character, all of these are basically ones and zeros under the hood. But we can't work with ones and zeros directly because we won't be able to decipher it. So we have high-level data types, and we deal with high-level data types. And Python deals with them behind the back and converts them into ones and zeros. Okay. And also one advantage of high-level data type is that they can be easily be manipulated, right? So for example, if you have text as a high-level data type, you can search it, right? You can, what else can you can slice it, right? Let's say Guido, you can slice it, take only part of it. What else can you do? You can join it, right? You can take two strings and you can join them, right? And you can set it to upper case or set it to lower case or capitalize. So you can do all kinds of things with data objects, high-level data types, okay? And all these high-level data types, integer, characters, everything, they are objects. They are objects. Objects means, in layman terms, objects are just self-contained elements, and you can do things with it. Okay, so that's object. And also, as I said, it is extensible, uh, which means that whatever features it comes up with, you can extend it. So, for example, it comes up with some inbuilt data types, right? It comes up with inbuilt data types, but you can create your own data types and use those data types as well. And as I said, it is interpreted, which means that it doesn't need to be compiled. It can just run as it is and can run in many operating systems. Okay. So what are some of the advantages of Python? One very obvious advantage is that very fast development time, right? So it is interpreted. So writing working programs and fixing mistakes in programs is fast, and it can be tested as soon as it is written. Okay. Uh, so quick programming. If you want to prototype an app, you can quickly prototype it, right? And then you can you know extend Python as well. And now I was talking about programming philosophies or programming paradigms, right? So programming paradigms and how Python supports all those paradigms or philosophies. Right? So one of the major paradigm or philosophy is object oriented programming, or OOP. Like for example, Java, is a object-oriented programming. So Python supports object-oriented programming, okay? And it also supports functional programming. For example, Erlang is a functional programming language, but Python supports both object-oriented as well as uh, functional programming as well. So let me give you some examples of other programming languages which are specialized in a certain philosophy. But Python has all of them. For example, Java, right? Java is an object-oriented programming language. So Python can do Java stuff. Right? Perl, right? It is a procedural language, right? And used for text manipulation, system administration, web development, network programming. Python can do the work of Perl as well. Then there is TCL. TCL is used for rapid prototyping, GUIs, testing, things like that. And Python can do all those things as well. Then there is Scheme. It is a functional programming, and Python can do that as well, right? So you can see that it is a very general purpose programming. And it can store, data, a special kind of data like sound, images, and it can manipulate these kind of data. So it can manipulate sound, it can manipulate images, it can do all those kind of things. And Python is used in all kinds of big organizations, just using Yahoo, just using Google, and Microsoft. Um, and the thing is that you can easily build like large application with Python. Yeah? But of course, it's not all roses, right? There are also some drawbacks to Python. The one biggest drawback is basically, that it is slower than in many cases, not all cases. In some cases, it can be slower than other programming languages like C and things like that. But personally speaking, I use Python in almost everything, except for maybe not for mobile development. I definitely use Python for web development. I use Python for machine learning and development, AI tools, those kind of things. I use all those kind of things. Also, it is not like a very good with graphic intensive applications. Like for example, if you want to make action games, then Python is not a program. And you have to use some other program like C Sharp or C++, or sometimes even Java. For example, Minecraft was written in Java. But for a game development, it's usually C Sharp or C++. All right. So we know in general what Python is. Now let's have a look at how we can work with Python. Okay. So in the terminal, I have written a very basic Python program called tem.py. Its content is like this. So if you want to run a Python program, you have to have this clause name is equal to name, because the Python interpreter looks for the main function and then executes it. And all it does is it just prints main. And the way we run it is, of course, we have to make sure that Python is installed in our system. We just write the keyword Python and the name of the file, and then run it. And then it gives, you see, it runs a program. But the problem is that this is a little bit slow for doing all these things, that you write a program and then you run it and test it and change it and then run it again. So it's like a tedious process, right? Even if you're doing a small change. So in order to test our program very quickly, we are using a Google tool. It's called Colab. So this, I'm using something called Google Colab. The Google Colab is basically if you go to your Google Drive and you can actually go to File. So for example, what we can do is we can go to New if you're in Drive, and then you go to More, and then you go to Google Collaboratory. Okay, Collaboratory or Google Colab, and then you will be able to have a new Google Colab notebook. Okay? So this is called Google Colab notebook. Basically, this is short for Colab. Okay. So once you have this thing open, you can see that you can quickly execute things in Google Colab. So for example, I can simply say print, and then either I can click on this play button or shift enter if I play that cell. First time it takes a little bit of time when you're running it the very first time, but after that it runs fast. It is allocating memory and all those things. So you see, I'm able to run this cell. Okay. And if you want, you can put a pause on it and whatever. So and you can have like code sections, code cells, or you can have text cells if you want to write news, right? So if I just want to write here, data types. Data types, right? So what are data types? So first of all, we can add number section. Numbers. So data types, different types of data. So numbers is one-side data. So numbers are the simplest of data types. You can just do 1 + 1, right? Or you can do 1 multiplied or 2 multiplied by 3, or if you do 1 divided by 2, so it gives you a float. And if you want to have 2 raised to power 4, then it is like this. So in Python, it is 2. This means something else. Okay? If you want to do something raised to power something else, we will do. Okay. Are we supposed to have this stem.py file already? No, you don't have to. I was just showing you how we run the Python program, but throughout this course, we will be using Google Colab. Okay, so you can also code along, or you can just watch and understand what I'm doing, and then later you can use Google Colab and look through the video and code along in the video. You can do that as well. So this is the power, and then also if you want to find a remainder, right? So if I do 5%2, is going to give me a remainder of 1. So I can find that as well. If I do 4%2, then obviously it will give me a remainder of 0, right? And we can also use like brackets and stuff like that. So 2 plus 3 multiplied by 1 plus 5, right? You can do this kind of thing. So, 5 times 6, right? So these are just numerical data type. And then there is something called variable assignment. Okay. So what is the meaning of variable assignment? So there is something in any programming language, actually, it is something called variable. Okay, variable means something that varies. You can change its value, right? So you can just have a variable, say x equal to 2, and then you can say print x or whatever. Then I can change the value to x equal to 6. Yes, you change the value, so it varies. Just remember that you cannot have start with number or character. You cannot have that. And also you can do operations on 2 variables, like x is equal to 2, y is equal to 2. I can do print x into 1. You can do that as well. Right? By the way, one good thing about Google Colab is that, let's say I have z is equal to 5, right? So instead of writing print z, if I just write z, it will execute, it will print it actually. Okay. But if I write x here, it's not going to print it. It will only print the last one. All right. So whatever is at the end, it is going to print it. But if it is not at the end, it won't print it. Then if you want to print it, you have to write it explicitly. So this is just to save some time. The last one, you don't have to write it. For example, this one, I can just write x multiplied by and it's going to print it. Okay, one more thing, in Python, you can comment out certain codes, right, by £. It's going to be printed. If you want to uncomment it, so either you can remove the £, or you can just do shift forward slash. Shift toggles or comment. So if I do shift forward, it will comment it. I do shift forward again, it will uncomment it. So it will toggle the comment. That's one hotkey that you know, instead of writing pound and then deleting it, you can just do this. Okay. So as I was saying, you can manipulate variables. You can do things to variables. And then there is so integers or numbers. There were one data type. Another data type is strings. So strings are you can write it in single quote. You can also write it in double quote. Yeah. You can also write it in triple quote. Yeah. So this is string, and you can do lots of things with string, which I will tell you in a bit. Um, and okay, so these are strings, right? And those were numbers. And then let's talk about a little bit about printing, because since we are at it, let's talk about printing. So how can we print things nicely, right? So let's say we have x is equal to hello. I just write here x. I don't even have to write print. I can just print here hello. But what if we have something like this? We have something like name is equal to Bob, age is equal to 32. So, right? And I want to write, and I run this cell so that it stores these variables in the memory. And then I want to print something like, hi, my name is Bob, and I am 32 years old, right? So how do we mix this, this strings with the variables that we have? So one way of doing it is doing it nicely is by something called format, string format. Okay? And the way we do it is something like this. So I can write here under quotes, my name is curly brackets. This is the um, this is basically the syntax for string formatting, and one is just a placeholder. Okay? And I am here. Okay? And then what we do is we put a dot there and then say format. And then we put the value like of the placeholders. The value of the one is equal to name, right? And two is equal to age. Okay. So now when we print it, we'll say that my name is Bob and I'm 32 years old. So what it is doing is that it is replacing. This means that this tells Python that this is a placeholder. Right? So what it does is it's going to uh, replace the value of this with this, and replace the value of this with this. And you can name it whatever you want. I have called it 1, 2, you can call it something else. But make sure that in the format you equalize it with some actual value. Yeah. And sometimes you don't even have to like even name it. You can do something like this. My name is this, and and then so what this does is that it takes it sequentially. So this is the first placeholder, the second placeholder. The value of the first placeholder, the value of the second placeholder. So you can do it. But if you have a very long string, then you have to, count that which number is which. So in those cases, it's better to have something else. And then there is even a better way of doing it. It is called the F directory. So, for example, I have a number one, and one is one, two is two. Then I can write something like print, and pay attention. I'm writing F, and after F, I'm doing this quotes or single quotes or double quotes. So remember that instead of just starting the whole thing with quotes, I am putting an F before that, which means that it is a formatted string. Okay. So in this case, I can write something of first name number. You see what it is doing? It is basically in the braces is directly taking the values, right? And then I can do backslash n. Backslash n is means new line. Okay. So let me do it without backslash n first. Second number is two. So now when I run it, we will see that first number one, second number two. Yeah. In here, if I instead of this, I just do backslash n, and it will simply be a new line. Okay. So remember that backslash n means new line. So if you want new line in just one line, you can do backslash. So this is how you can format print and put it, print things nicely. Okay, so we have dealt with basic data types. We have dealt with how to print things. Now let's have a look at some of the objects that Python comes with, some of the useful objects with some very useful properties. So one of the very useful objects is something called lists. So in lists, so list is simply like this. You enclose anything with square brackets, it becomes a list. So this is a list. And I can mix and match different data types as well. And I can this is also legit in Python. Some programming languages complain about it. They don't take this as valid, but Python takes this as valid. Okay. And of course, you can assign a variable to the list, like I can say my list is equal to, let's say, A, B, C. This is my list. So if I actually print my list, you can see this A, B, C, right? But sometimes what happens is that we have a list and we want to add to that list. So how do we add to that list? So to add to that list, we simply call a function or a method of the list class. So we first of all, the syntax is following. We write the name of the list dot, then append, and then enter whatever you want to append. So as you know, the English meaning of append is to add. Right? So if we run it, you can see that now the list has a new element D, which we had just appended. So it just gets appended at the end. So okay, we have a list, we have appended to the list. How do we access the members of the list? We can access the members of the list by its index. Okay, so in almost all programming languages, including Python, the index always starts with 0. So A here is at the index 0. B here is at the index 1. So on and so forth. So if I just print my list index 1 is going to print B. Okay. See here, it has printed B, right? If I want to print the first element of the list, 0. So it's going to print me A, right? If you want to print the last element of the list, there are two ways of doing it. One way is that, of course, I count 0, 1, 2, 3. I can do that. I can do my list 3. But there is an easier way of doing it if you want to print the last one, right? So We just write -1. -1 means the first element from the last. So it will also be. Okay. And again, if I do my list -2, it is going to give me the second element from the last, which is C. Okay. So we are able to extract individual elements from the list. Yeah. But we can even extract parts of the list. Okay, we can extract a slice of the list. So for example, if I say my list, 1, 2, 3, it is going to give me B and C. Okay? So remember, the index of B is 1, index of C is 2. Okay? So it will go on till the end of this, which is 2. Okay, so remember that here 1 is inclusive, and 3 is exclusive. What does it mean? 1 is inclusive, 3 is exclusive. So in here, when we are getting a slice of the list, then 1 is inclusive means it means that it will contain the first element. Okay, it is inclusive. 3 is exclusive, which means that it won't contain the element with index 3. It will stop at 2. So whenever you write 1:3 or A:B, A is inclusive, B is exclusive. So just remember that. Okay. What if I do my list 1:, but I don't give the second parameter to it? What will happen then? It will simply start with the index 1 and go till the end. So if I don't write anything, which means that go till the end. Okay. What if I do my underscore list and colon and then 3? What does it mean? It means that start from the beginning and go till 3 excluding 3. Yeah? So 0, 1, 2. Yeah. So instead of doing 0, 3, so this is actually equivalent to my list 0, 0, 3. Okay. And this is equivalent to my list 1 till -1 or the end. Okay. So if you don't write the second part, it automatically assumes that we want it to go till end. And if you don't write the first part, it automatically assumes that we want to start from the beginning. Okay. So just as a reminder, let's see. This is my list, right? Okay. So what if, and we know that my list 0 is 2. Yeah. But what if I write something like my list 0 is equal to, let's say, what will happen then? Let's find out. Okay. And then if we print my list, we will see that the 0th element, which was A, it is replaced by a new element. So if you directly assign things like this, it will replace the old value with the new value. Yeah. So this is list, and with list you can do lots of complex stuff actually. So for example, you can have a list inside a list, right? So it is called a nested list. It means that list inside a list. So an example of a nested list would be is equal to 1, 2, 3, right, and then 4, 5. You see, this 4, 5 is like a list here, right? And then even inside that we can have another list. Yeah. So you see, there's a list inside a list inside a list. Okay. Print here. We have something like that, right? So if I want to access the third element, right? What is the third element? 0, 1, 2, this. This is the third element. Yeah. So if I just print the third element, you will see that it is printing this particular list, right? So the third element is a list itself, right? Which means that we can access that list, elements of that list as well, right? So this nest 3 is a list as above. The first element is 4, right, on that list. So we are able to get 4. Yeah. And then nest third element. What is the uh, what is at index 2 of this particular list? It is again a list, right? So if you want to, access the first element of that list, you can access it like this. So you can see that we have list inside a list inside a list, and we can access the nested list this way. So it is a good data structure. List is a very good data structure. You can do lots of things with list, right? So that's pretty good. But sometimes we need a different data structure. Those data structures are called dictionaries. Okay. Yeah, these are called dictionaries. Before I go into dictionaries, any questions about the list or whatever I taught before that? Okay, let's talk about dictionaries. So, as you know, in dictionary, what actually happens is that um, in a dictionary, right? Let's say in a common dictionary that we use, we have a word and then the definition of the thing. Right? So this is the key, and this is the value of that key, right? So any kind of a series of key value pairs is called a dictionary, right? So I can have a dictionary. Let's say, for example, we have a dictionary of username and password. I mean, we won't actually store it this way, but I'm just giving an example. So a dictionary can have Bob as key and password as, and then we have Alice as key and my password as. So on and so forth. So we have key colon value. Okay. So a set of such key value pairs is called a dictionary. Okay. So let's see how dictionaries are, what we can do with dictionaries in Python. So the simplest way to write a dictionary is like this. And dictionary, so remember, list starts with square brackets. Dictionary starts with curly brackets. So we have P1, item 1, and we have P2, item 2. Yeah. So if we print the dictionary, it will be something else. This is dictionary. And the way to access the dictionary is we say D in square brackets, the key. So if you look at it, we are able to access the value through the key. Okay. And also in dictionary, the duplicates are not allowed. I mean, duplicate keys are not allowed. Okay. So if I have something like this, P1, P2, sorry, P1. Again, if I do P1, and if I write, let's call it D2. If I try to write it, it's going to give me a problem. It will be problematic. So you see that this key one, the value of this key one is overwritten by the second value. So that's obviously a problematic thing. Yeah. And also, if you want to find the length of a key or of a dictionary or a list, we have this keyword. Why is it? Okay, I think my computer is running too many processes. Let me close some of them down. Just slow it down. All right, so I was saying that you can find the length of the list or dictionary through a keyword called len. Len, right? So again, remember that I'm not writing print len b. In actual Python program, you have to write print. But because I'm using Colab, I don't bother to write print automatically. So you see the length of B is 2. And similarly, we have this dictionary nest. If we just do length of that dictionary nest, is going to give me the length of that particular dictionary. Yeah, you see 4, right? Also, another cool thing in Python that you can do is that if you don't know if something is a dictionary or a list or what it is, you can simply say type, and then let's say I do this type. It's going to tell me that it is actually a list. If you say type in, it will tell me that it is a dictionary. Yeah. So if you want to do certain operations, you need to know that what object that is actually. Right? And if you're not sure about the object, you can simply find it out through this type keyword. Right? So I showed you a way how to construct dictionary through curly brackets. There is another way you can construct it. It's good to know. Is through the dict keyword. You can say is equal to Bob, right? And page is equal to 32, and three is equal to and then if I write this, we can see that it's a dictionary. You can have a dictionary like this as well. And if you want to change the value of a dictionary, you can do that simply by this. Let's say if I want to change the value of A from 32 to 33, I can do that as well. Yeah, I can do that. Right? So we can do some code operations with dictionary. Now let's okay, one more thing you can do is, let's say if you want to just know the keys of a particular dictionary, you can do that as well. You can do something like let's say this dict, right? Keys. It will give you a list of all the keys. Okay. Okay. The keys name, age, country. Yeah. Okay. Let's move a bit forward from there. All right. One more data types other than string or integer or float is it's called Boolean data type. It's also a very important data type actually. So Boolean data type are either 0 or 1. So either true or false. Right? So A will be true, B will be false. So if I do print A, okay, giving true and false. Okay. And we can do something like A is equal to not A. So what do you think will happen? So it will change the value of A from true to false. So whatever A it was, flip its value, right? So we can just say A is equal to not A, but flip its value. It's like flicking a switch on and off. So that is Boolean variable. There is also another data type called tuples. So tuples are much like lists, but they are immutable. Immutable means you can't change them. In some cases, it is important that you don't accidentally change the value. So let's say you get a value from somewhere, from a database or from some API, you get a value. And if you store it in a list, you might accidentally change it, or some other part of the program can accidentally change it. But you want to ensure that you don't change that value, so you use tuples. So in tuple, it's just like list, but it starts and ends with round brackets instead of square brackets, right? And just like list, you can actually access its value, but you cannot change its value. Remember that in list, you are able to change the value to some new value, right? If you try to do it, it will be an error because it's a tuple, so you cannot change the value. Once we have the values in a tuple, it's just good for reading, right? So if you want to manipulate or do something with values which you don't want to accidentally change, and for that you use tuples instead of list. Okay? And then there is another very important primitive in Python called the sets. And this set also, it comes from the mathematical set. So the way you create a set is through curly brackets. So remember that dictionaries also have curly brackets, but in sets you don't have any like key value pairs. You just have values, right? And just like in mathematical set, a set can have only one unique value, right? So, for example, if I write 1, 2, 3, 1, 3, 1, 2, 3, 5, 3, 4, 1, 1, 1. Right? So you can see that it always gives me unique values. This is pretty good because let's say you have a bunch of value and you only want unique value. So instead of doing it on your own, you just pass it through a set, and a set will only give you the unique values. So it's pretty handy. So all these things are there, but obviously when you are programming, you want to apply some kind of logic to it, right? So you want to compare things, you want to equalize things. So in order to do all that, we have something called comparison operators. So comparison operators are, they give you true or false. If something is true, it will give you true. If something is false, it will give you false. As simple as that. So if I do A more than 2, it will give me false. If I do one more than 2, it will give me false. If you do a 1 less than 2, it's going to give me true. Right? So on and so forth. You can also compare like strings. So if I say x equal to high, y is equal to bar, z is equal to high. And then if I print x, okay, so greater than operator, less than operator, equal to operator. It is comes with 2 equal to. You have to write 2 equal to y, because if you write 1 equal to, then you're assigning it. So here we are assigning the value of I to x. So a single equal to operator means assigning it. Okay. So I'm telling the computer that take this value of I and put it in the variable x. But when I'm saying x equal to I, I'm asking the computer, is it true or not? All right. So that's the difference between single and double. Okay? So this is assignment. Okay? And this is basically, it gives you a Boolean result. So if I do print x equal to y, it will ask the computer, is x equal to y? If it is true, then it will return true. If it is false, it will return false. Right? So if I run it will return false because x is not equal to y. But what if I write z? Right? It's true because x is equal to z. So it will return true. Okay? So this is a comparison operator. And you can also have other comparison operators like 1 more than equal to 10, less than equal to 3. So this is true because 1 is indeed less than equal to 3. You can also do something like You can also do something like X is less than Y. So it will give you false because in the dictionary, in the actual dictionary, high comes after by. So therefore, high is more than by, more than by. Okay. So you can do this kind of dictionary comparisons as well. So Python is smart enough to know that if you're comparing strings, it means that you are talking about the dictionary greater than equal to. But if you're comparing numbers, then it means the actual, greater than or less than equal to operator. So these were the comparison operator. Then there is something called logical operators as well, right? So logical operators is used to evaluate more complex logical organisms. Uh, so for example, I want to see A is more than 2 and 2 is less than 3. So this will result in true only if both the statements are true. Only if both this is true as well as this is true, only then it will evaluate to true, right? So, but we know that this is true, but this is not equal to true. So it is going to give me false. Yeah, it's going to give me false. Yes. But if we do something like 1 is greater than 2 or 2 is greater than 2. So in this case, if only even if only one of them is true, it will evaluate. So this is going to evaluate to true because even though 1 greater than 2 is false, but 2 less than 3 is true. But if both are false, then of course or is also not going to evaluate to true. It's going to evaluate to false because both the statements are false. Okay? And of course, you don't have to like have only two compound statements. You can have as many compound statements as you want. So if I can have 1 equal to 2 or 2 equal to 3 or 4 equal to 4. So this is going to give me true because at least one of them is true. So this one is true. So you can have like many statements. You can combine them with and or. Okay. So you can so these are operators, comparison operators and logic operators. Right? But now the question is, what are you going to do with these kind of operators? Exactly how are you going to use them? So let me show you how we can use them. So now you see the code will get more and more complex. So we can have if, else, if, else, else. So we have something called if statement in Python. So if we write if 1 is less than 2, then it is going to print here because this is true. Okay? But if it is false, it's not going to print it, right? Also remember that I told you that Python enforces good coding practices, clean coding practices. You'll see that after if this block, there's like a tab over here, right? Because this print here, it belongs to this if statement. So if I remove the tab, it's going to give me an error. Okay? But if you go with the tab, then it will be fine. Because this block of statement, actually, if I write here, right? So this whole block of statement, it belongs to this particular if statement. So if I indent this also, this won't give me a problem because now it means that this print yes is outside the block. Okay. So right now it will still print this, but you will see now it's only going to print yes because This print yeah is inside the if block, but print yes um, so but print yeah is inside the block, so it won't be printed, but print yes is outside the block, so it will be printed. Okay. So this is the if statement. Okay, so remember that whatever is inside the block, inside the if block, it will be executed if the condition is true. It won't be executed if the condition is not true. And then there is something called if else statement, right? So if I can say if one is less than two, then print first, and then else. Okay, else means what if it is not true? Then what are you going to do? Okay. So it is going to print first because this statement is true, and it won't execute this statement because the else statement is not true, right? So if I do the 4, you can see that then it will only print the second one because the statement is not true, so it won't go into this block, but will go into the else block because it is false. Okay. And you can have like many if else kind of things. So for example, I can have something like if 1 equal to 2, print first. And elif is short for else if. Okay. So what I'm saying is that if statement is not true, then evaluate another statement. And at the end, if nothing is true, then evaluate this. So you will see that it will only print the middle one because this statement is false. So it comes here. Then it checks, is it true or not? If it is true, then it will execute this and that's it. But what if this is also false? Then it is going to, and then the logic will run like this. Is this true? No, this is not true. So then we'll check, is this true? No, this is also not true. Then it will come to the last, right? But what if the first statement itself is true? Then it will just print the first and won't even bother to evaluate the other elif or else statements. Okay? So this is how you can use if-then statements and the logical comparison operators to execute the flow of the program. Okay. All right. So this is the if statement. Another important directive is the for loop. For loop. Yeah. So the for loop is basically, as the name suggests, it is a loop. Okay. So let's say, for example, we have a list, right? A list of 1, 2, 3, 4, 5. And then I can have a for statement for item in the sequence. So what I'm saying is that for each item in the sequence, print item. So it will iterate through all the elements of this list and print it. And remember that this item is just a dummy variable, so I don't even have to necessarily name it item. I can call it I. And it will still work because it's just a dummy variable, it's a placeholder. I can even do something like print I into 2. See, it's going to print the double of each element. Okay. I can even do something like for I in sequence print So for each element in the list, it will just print yes. It will go through each element, print yes. So even if you're not doing anything with the element, you can still do something while it is going through, you know, the thing. So that is for loop. Uh, okay, remember that we had tuples. Well, we also have something called range. So if I do range 4, it will give me, range from 0 to 4. If I do range to 6, it will give me range from 2 to 6. If I do range to 6 and I step 4, like skip 2 each time, I can have that as well, right? So I can run for loop for range as well. So I can do for I in range 4. Okay? Print I. It is print I 0, 1, 2, 3. So remember that I told you that when we are dealing with lists or even with tuples, the n index is not exclusive. So when I say range, I mean to say 0, 1, 2, 3. I don't mean to say 0, 1, 2, 3, 4. Okay, so always remember that. But instead of this, if I just say range 2 to 6, okay, then what it will do is it will start from 2, 2, 3, 4, 5, but not 6. Okay, so again here we can see that here also we can see that uh, 2 is inclusive and 6 is exclusive. So we exclude the 2. Okay. So it is this is how it's going to print. And again, if we want to say for I in range 2 to 6, step 2. So it's going to start with 2, and then instead of 3, it will go to 4 because it is step 2, right? So let's say if I do it 10, that will go 2, 4, 6, 7. If I do step 3, it will go 2, 5, 8. And then 11, but 11 is like more than 9, right? So we can do steps as well, right? So we learn about range and we also learn about how to use a for loop, right? So there is always a syntax is for I in something. It could be a range, it could be with IGF. So that is for loop. And then there is something called while loop. While loop means it is simply a loop which keeps on going till some condition is true. Okay. So for example, let's say I is equal to 1, right? Say while I is less than 5, print I is, yeah. And then I increment the value of I from I to I plus 1. Okay. Before I do that, let me just tell you this thing. So for example, we have, let's say, and j is equal to 4, right? So if you print j, it will be 4, right? But if I do j is equal to j plus 1, if I do print j again, it is going to be 5. If I do j is equal to j minus 3, so 5 minus 3 is 2. It is going to print 2. So we can change the value of variables like this as well. So initially it is 4, j is equal to j plus 1 becomes 5. Then j is equal to j minus 3, 5 minus 3 becomes 2. Similarly, we are just increment the value of I. So what this is going to do is that it's going to start from I, and it's going to check, is I less than 5? If it is true, it is going to execute these steps. Okay. So if I execute, you will see that it is writing I is 1. Then the value I becomes I is y plus 1, 2. Then it goes in the beginning. It checks, I is I less than 5? Is true, because 2 is less than 5. Then we'll print again, increment the value 3. Then it will go on till it is I is equal to 4. Then it will ask, is I less than 5? True, it will print 4. Then the value of I becomes 5. Then it goes back again and then asks, is I less than 5? Is 5 less than 5? It is false, right? So then it will stop there. So while statement is going to continue until a certain condition is true, as long as a certain condition is true. And the moment that condition is not true, then it will come out of it. Okay. Okay. Then there is something called list comprehension. List comprehension is kind of like a shortcut. Let's say I want to, I have a list here. One, two, three. I have a list here, except for this. And then what I'm going to do is I'm going to create a new list for I in, and you say out dot append I raised to power 2. Okay. And then at the end of it, I'm going to say print. So what it is doing here is that it's taking an empty array and it is iterating through the elements of this list X. And then it is appending I raised to power 2, like square of each element in this array. And at the end, I get this array whose elements are squares of this particular array, right? So it took like many lines for me to do it, but actually I can do it in just one line. You know, I can simply say, let's say out2 is equal to I raised to power 2 for I in X. That's it. And then it's done in just one line. So this is called list comprehension. Instead of looping through each element of the list and transforming it, we can do it in one go. We are simply saying that I raised to power 2 for each I in X. We don't write the keyword each, but that's what it means. I raised to power 2 for each I in X. Then this out. Okay. So already you can do a lot in Python just by doing this. And then I will teach you one more thing called functions. And just by using this, you can actually do lots of complex things. So function is simply a block of code to which you give it a name, and you can call that block of code by its name. Right? So for example, I can say write basically the syntax is something like this. You give it a parameter 1 is equal to default, and then there is something called doc string. In which you are describing that function for human readable thing. Let's say I like I just define my function. Okay. So if I just print this function, I just print it. Data history. It's back. So in 2 minutes. Okay, so when I run it, this my function is going to simply say that, this is some kind of function, right? And if I do like, if I do a type to it, mount function, it's going to say that it is of the type function, right? And you can run this function, right? It's a my function, and because it has one parameter, I can give the value of the parameter to be, let's say, what it's going to do is it's going to take that parameter and just print it, because that's what it is instructed to do, right? Uh, or if I had instructed it to do something like this, something like this. So if I instruct it to do something like this, then it's going to do exactly that. It's going to show an arrow mark, and then yep. So you see here, it basically takes whatever I give it to function and puts it here. Okay. And if I don't give it anything, then it will go by the default. If I just run this function without giving it anything, it automatically then takes this as a default. Okay. My default. So if I run it, it will simply print my default. Okay. So you can create a function and you can give it a default to that function. Right? Okay. So that is a function. Then you can also give it a list instead of giving one parameter at a time. You can give it a list of parameters at once. And a function which accepts a list, its format is something like star and then the variable, the name of the list. Usually we call it args, means arguments, right? So let's say this, I'm writing a function which something like this, and then return some. Okay. So you can do something like this, right? So it will return you the sum of whatever you put in the list. So what this function is doing is that it is taking a list, okay, and then it is going through the list and it is adding that list to this particular placeholder. It is appending it, and once that list is complete, it will finding the sum, right? So it is very good for let's say actually let's call it my ad so that you don't get confused. So if I say my ad and give it a list of arguments like 6, 7, 9, right? So Excel. So it will give me the sum, right? So this is going to, what it is going to do is going to take all the arguments, put them inside this list and find the sum and return that sum. So one good thing about returning a value is that you can store that value. So I can say my sum is equal to, my add 1, 2, 3. Okay. So you see 6. So my sum is equal to 6. So it is giving me the sum of all these numbers. So simply by knowing, these functions and list comprehension and dictionary and while loop and for loop, if statements, logic operators, comparison operators. So just by and tuples, booleans, just by knowing these things, you can do a lot of stuff actually, like a lot. All right. So already you can do a lot. So let me just teach you a little bit more advanced. All right. And then after that, I'll stop because otherwise you won't be able to digest it. Okay. So there is something called map filter. And so map filter goes something like this. Let's say you have a sequence equal to 1, 2, 3, 4, right? You have this sequence. And then you can say map, right? So you can do okay, actually, first of all, let me create a function here for times 2. Okay. So what times 2 will do is that is going to we're going to take two numbers, x and y, and actually we're going to take one number, x, and we to input x. And then what I'm going to do is I'm going to say times 2. Okay. So I'm going to convert this map into a list. So I just say list map. Oh, sorry. So you see what a map function does is that it basically takes a function and takes a list. And then what it does is it applies that function to each element of that list. See, so this function, what it is doing is it's multiplying a number by 2. So I give it the function and I give it the sequence. It applies this function to each element of the list and gives me a map. And then I convert that map into a list by the keyword list. Okay. So as simple as that. So I can even do something like list map times 2 range, right? 2 to 6. I can do this as well. So from the range 2 to 6 means 2, 3, 4, 5. it will apply this times 2 function to all. And then there is something called filter, right? So filter is, again, it takes a function and um, and that function has to return a boolean. So let's say I wrote a function called even x turn x %2, right? So it will return true or false, right? So if I say even 2, it is going to return me true, right? If I do 3, then it's going to return me false. So if I do list filter, then I give it a function even, right? And then I give it the give it a list like range 6. So you see, it will filter out only those values which gives true, right? So the range 6 is 0, 1, 2, 3, 4, 5. So 0, this will return true for 0. So it gives me 0. This will return false for 1, so it won't give me 1. It returns true for 2, it will give me 2. It does not return true for 3, it won't give me 3. It returns true for 4, it will give me 4. So this is filter. Okay. So this is map. So what map does is, a map, it takes a list, right? 1, 2, 3, and maps it to another list, which is some function of that list. And what filter, so this is map. And what filter does is, it just filters out the value. Okay. So it filters out the value, and map maps each element of the list. So this is a difference between map and filter. And just by knowing map, filter, function, and all these things that I've told you, you can do lots of complex things if you just join them, if you do them creatively, right? So the things that we learned here, there's a lot to go for you to practice. You can watch the video and you can practice it. Different variables and strings and how to print properly. What are lists? What are the things we can do with list? And then what are dictionaries? What are the things we can do with dictionaries? What are Boolean values? What are tuples? What are sets? Comparison operators, logic operators. What we can do with those logical operators using if, elif, and else statements. You know, and how we can run for loop. Inside the for loop, you can have some kind of if then else statement. All right. This you can just actually what I suggest you do is that because this video will be uploaded in the LMS. So what you do is you create your own collab. As I told you, you go to Google Drive, and in the more options, you can have a Google collab, and you can open up your own collab, and just as I'm teaching you, watch the video and do it on your own. Okay, and see that you're getting results, right? And then, of course, there are dictionary and Booleans, and then you can have if then else statements inside functions, and if you want to filter a list, you can filter it. If you want to transform a list, then you can use map, and you can do lots of things with this just by doing this. And if you want to run Python in your own system, then you'll have to install Python. But I would rather suggest that if you're a beginner, don't do that. Just go to Google Colab, because your whole environment, Python environment, is set up in Google Colab, and you can just do the exercises there. And then when you go more advanced, then you can install Python and do all kinds of more advanced stuff. But even with this, you can do lots of things. Just I know that there's lots to digest, especially the later parts. So you watch the video slowly and then understand and practice it.